Thank
because
you.
that's probably what you're doing, right? All right, so
Yeah.
what do the directions say for this?
Basically it just says determine the open intervals in which the given function is increasing, decreasing, and coordinates of any relative extrema. So
And do they not want concavity for this one?
for this one, no, but that's in like
Okay.
a couple of questions.
Okay, so increasing and decreasing would just be, you're going to take the derivative, you're going to find the derivative and set it equal to 0. Those are your relative extrema, where either the numerator or the denominator equals 0. Okay, and then you're going to use that plug in points to see where it's increasing or decreasing, because anytime the double derivative is positive, or the derivative rather is positive, it's increasing. And anytime the derivative is negative, it's decreasing.
Yeah.
Does that make sense?
Yeah. Thank
Okay.
you.
So the first thing we're going to do is rewrite this just to see if we're able to cancel something out. So this is x plus, sorry, it's x minus 4 and x plus 1, right? It's good to have it like that, just so we can see what it looks like. Excuse me, because you remember how to graph this, right? Remember doing that back last year, graphing this, and it would be because the numerator is 1 more, the degree is 1 more than the denominator, you're going to have a vertical or a slant asymptote. This is going to give you your vertical asymptote. This is going to give you your zeros, right? So we can actually pretty quickly just kind of sketch this out real quick without even using a calculator, and we can see what it looks like. We know it's going to be an asymptote at 2, right? It's going to have a slant asymptote that goes through x. Let's do this real quick. X, just as a form of review. Now, this is not what you have to do in calculus, but I'm just showing you to give you a visual, right? So we're gonna, how many times does x go into x squared? Goes in x times, multiply it, you get x squared minus 2x. And we're gonna subtract that. So it's gonna be a negative x minus 4. And then that's gonna be negative 1. So that's your slant asymptote. So it goes through negative 1 and it goes up like this. Got it? And do you remember doing this?
Yeah.
And these give you you see that negative 1 is going to be one of your zeros, and positive 4 is going to be one of your zeros. And you know your y-intercept is going to be positive 2. I found that by plugging in 0 for all the x's. So I just basically eliminated all of those. So it's negative 4 over negative 2, which is positive 2. So there's your y-intercept. And so you can see what your graph's going to do. Your graph's going to go like this, approach there, and it's going to approach down there. And then it's going to approach here and approach up there. So we can actually see where it's increasing and decreasing. It's actually increasing everywhere. But we're going to say it's increasing from negative infinity to 2, and then from 2 to positive infinity. And it's never decreasing, and there are no relative max or mins. So we can see all that. Now so that's how we would have done it last year in pre-calc. Now let's do it with calculus. Okay? With calculus, what you would do is you would take the derivative of h of x, and the way we take the derivative is low times the derivative of the high, which is 2x minus 3, minus high, x squared minus 3x minus 4, times the derivative of the low, which is just 1, all over low squared. Right? You follow that?
Yes.
Okay, so let's simplify that. So that's 2x squared minus 4x minus 3x plus 6. Let me know if I make a mistake with that anywhere. Minus 4x minus, that looks right. And then distribute the negative in. That's going to be a negative x squared, positive 3x positive 4 all over x minus 2 squared, which means, let's add like terms. That's x squared minus 7x plus 3 is minus 4x and plus 10 all over x minus 2 squared. Got it? So that's my double derivative, or that's my derivative, my single derivative. Okay. Now, does that factor? The top of that doesn't factor at all, right? So what we want to find anywhere where either the numerator, so critical points, relative extremists come from critical points. Critical points, I think, is what they don't they use that terminology for you? Have you started talking about it like that?
About it like what? Sorry.
Critical points. Have you been using that term?
No, I don't think so.
You haven't? Okay, so maybe you'll be doing that once you get to the double derivatives. You set each one of those equal to 0, basically. So the numerator, setting the numerator equal to 0, I'm gonna have to use a quadratic formula. Remember this? So x equals the opposite of b, which is positive 4 plus or minus the square root of b squared minus 4a, which is 1, c, which is 10, all over 2a, which is 1. And that's going to be a negative number. So this is going to be a imaginary. This is going to be an imaginary number. So there are no x-intercepts. I'm sorry, there's no x-intercepts for this double derivative. Sorry, for the derivative, right? Which means there are no relative extrema.
Well, what about for the denominator?
Yeah, and then so for the denominator, when we set that equal to 0, we see that x equals 2. So, the only point we have to worry about is 2. So let's make a real number line, and there's 2, and we're going to evaluate. We're going to analyze it on the left and on the right. So let's plug in a 0. Let's plug in f prime of 0, because that's on the left over here, right? And when I plug in 0, I get I'm plugging it into this equation over here. That's gone. So it's 10 on the top and it's 4 on the bottom. So is it a positive or a negative value?
Positive.
Positive. And that means it's increasing in that area. The graph, the f of x, or h of x, the original function, h of x is increasing in that, from negative infinity to 2. It's increasing. Okay. And now we're going to plug in something on the right. Pick a number on the right of 2, to the right of 2.
3.
Sure, good choice. So when I plug in 3, remember I'm plugging it into here. I'm going to get 9 plus 10 minus 12, which is a positive, right? I'm going to get a positive. I'm just trying to figure out if it's a positive or negative, divided by, and what's the denominator always going to be since it's squared?
Positive.
It's always going to be positive, so I don't even have to worry about plugging it in there. So that's a positive, which means it's what? Not h prime. H of x, the original function, is increasing in that interval. So from 2 to infinity, it's increasing. Right? Well, if it's increasing on the left and it's increasing on the right, is there a max or a min? In order for there to be a max or a min, it would have to be increasing and then decreasing, or decreasing and then increasing. But because it's increasing on both of them, we know there's no max and there's no min. In fact, that's why I drew this picture for you, so you could visualize it. This is my h of x graph right here. Can you see what's happening from negative infinity to 2? That's on this part of it. It's doing what?
It's concave up.
It's increasing, right? It's increasing. This doesn't tell us anything about the concavity. but it's increasing from left to right. You're right. You can see that it's concave up. And then from negative 2, or from 2 to infinity, just to the right of 2, it's also increasing. So that's an example of a graph that is increasing on those two intervals, which means there's no relative extrema. Now, the next question would have been, is it concave up? Where is it concave up and where is it concave down? In order to find that, you would take this equation and take the derivative again, and then do this same thing again, sign analysis, and it would be concave up and concave down. And what you would find if you did this is on the left, when you plugged a point in, it would give you the double derivative would have been positive, and that's why it's concave up. And if you plugged in something on the right, the double derivative would have been negative, which means it's concave down. But this one didn't ask you to do that, right?
I'm sorry, you kind of went out for a little bit when
Okay.
you circling
Do you? Yeah, I'll re-explain it. Do you need to do concavity or no? Or double? Yeah. Do you have to find concavity in this problem or no?
no, not this one.
Okay. If you did, I'm not going to do it. But if they asked you what's the concavity, the way you would go about that is you would take the derivative of this, which means you're finding the double derivative, right? H double prime of x. And then you would do the same analysis, real number line analysis, for any points that you found. And the points that you would find would be the same. You would have still just found the point of 2. So all you'd have to do is plug in something to the left of 2 and to the right of 2. And you would find, if you did that, you would find a positive. The double derivative, when you plug something in, would have been positive on the left, and it would have been negative on the right. The reason I know that is because I look at the graph, and what do you see? Like you mentioned, the concavity on the left of 2 is positive, or concave up, and the concavity on the right of 2 is down, concave down. So that would be a negative double derivative. Okay.
Oh, okay. But I also wanted to know, since the exponent on the top, this is kind of going back to the graph.
Mm-hmm.
Since the exponent on the top is greater than the exponent on the bottom,
Mm-hmm.
wouldn't
That means there's no horizontal asymptote.
Oh, really? I thought it meant
Yeah.
it was at y equals 0.
No, when it's top heavy, that means there's no horizontal asymptote. When it's bottom heavy, if this was a 3 down here, then it would be 0. But when the degree on the top is bigger than the degree on the bottom, there's a slant asymptote, but there's no horizontal asymptote.
Oh, okay. And then also every time there's like a fraction like this, because to be honest, I did it the hard way, which was
Mm-hmm.
I multiplied x minus 2 squared to the numerator and to the 0 side too.
Mm-hmm.
But would you use the quadratic in order because I realized it wasn't factorable, so then after that I tried to use the quadratic formula and it didn't work.
Mm-hmm. Well, the
So-
quadratic formula would give you an imaginary number, which basically means that there are no real solutions for that. So you don't have to worry about the numerator.
Oh, really?
For these extrema. Yeah, that's what that means.
Oh, okay. So, does that mean that if you have to use the quadratic formula, like if the
Well,
equation
we could have had the quadratic formula could have given us real number answers, but it didn't in this case. If it did, it would just you would be these points that you would include here would have to be some irrational numbers, like 2 plus or minus the square root of 3 or something, right? So it just would be a kind of a weirder number, but you could still do it. It still work.
Okay. And whenever you have like a fraction like this, would you just do it to the numerator in the denominator equals 0? Would you just set the new
Both of them. Yep. Set them both equal to 0. Yep.
Oh,
Whoops.
okay.
Sorry about that. Hold on.
Oh, no, you're fine.
Can you still see my screen?
Yeah, I can.
Okay. I have do not disturb on. I thought, oh, maybe not. Do not disturb. Sorry about that. I'm getting phone calls from my daughter and from my parents. I'm a popular person today. All right. So do they want us to do concavity for this one?
For this one, yes.
So the first thing we're gonna do is take the derivative, and that's gonna help us find increasing and decreasing. So to find the derivative of this, I'm gonna use the product rule, which is the first times the derivative of the second. Now the derivative of the second is gonna have to be a chain rule thing. I'm gonna bring down the 1/2 because that's a 1/2 power, right? You with me?
Oh, yes.
See
Yeah,
how I did that? And now I'm gonna multiply that by the derivative of the inside function. What's the derivative of this inside function?
negative 2x.
Perfect. So that's the first part, plus the second part times the derivative of the first part, which is just 1. Okay, so let's clean this up. This equals, now notice these 2's are going to cancel. The 2 and then on the top and the bottom are going to cancel. And we're going to have x squared on the top because there's an x here and an x here, and those are both in the numerator, right? So I have a negative x squared in the numerator because I still have that negative, divided by the square root of 9 minus x squared. You follow?
I follow everything except, oh, never mind, it's a product rule. I don't know why I thought it was a quotient rule. My bad.
And now I'm going to get a common denominator. So I'm going to have to put this in the denominator, right? Which means I multiply it on the top and bottom, right? Which means on the top, it's that square root's going to go away. Follow what I did there?
Yeah, but wouldn't,
I'm getting a common denominator.
oh, yeah. Oh, right, that makes sense.
Makes
Sorry.
sense?
Yep.
Okay. Now I'm going to add the numerators together. So that's going to be a negative 2x squared plus 9 all over the square root of 9 minus x squared. Okay, so that's my derivative in simplified form. And the reason I wanted to simplify it is because now I can set the top and the bottom equal to 0, right? So if I set this equal to 0, what are my zeros?
That would,
So let's do the math over here. Ready? Negative 2x squared plus 9 equals 0, which means negative 2x squared equals negative 9, which means x squared equals 9 halves, which means x equals plus or minus the square root of 9 halves. Got it?
oh, one thing that, like, I just want to clarify that that's more of a general question would actually be, why do you do like a plus or minus whenever you have to square root an x here, but whenever you like,
Because if I told you that x squared equals 9, what could x be?
oh, I guess 3 or negative 3.
That's right. That's why.
Okay.
But if I told you that x equals the square root of 9, I'm not asking you for the negative one. I'm telling you that x equals the square root of 9, which is a positive value, right? I'm not saying that x squared equals 9. I'm telling you that x equals the square root of 9. And so you don't have to introduce a negative into that one. But if the equation if it's a squared in the equation, there's always going to be 2 answers for that. A positive, or, kind of like a positive and a negative value.
Oh, okay.
Okay. Okay, and what is the denominator? So now I'm going to do the same thing for the denominator. I'm going to say that the square root of 9 minus x squared equals 0. So what would x equal? 9 minus x squared equals 0 still, which means 9 equals x squared, which means x equals what?
Plus or minus 3.
Good. So there's actually 4 numbers that I have to be careful about here. There's 4, or that I have to check. So let's do that. Ready? Here's my number line. and I'm going to put the numbers -9/2. So that's the square, sorry, that's the square root of 4/2, which is like, it's like a little bigger than 2, right? So -3 is going to be here. Negative square root of 9/2 is going to be here. Square root of 9/2 is going to be here, and 3 is going to be here. Okay. If you're not sure about that, let's do it in the calculator real quick. Okay, so the square root of 9/2, square root of 9/2 is going to be 2.12. Okay.
Okay.
All right. So what we're going to do is we're going to plug in each one of these regions. We're going to plug in a value, right? So let's plug G prime of, what should we plug in left of 3?
I guess 2.
Let's go -4. Left of 3 would be -4.
Oh, you mean, oh, left of -3, my bad.
Sorry, you're right. I said 3. Left of -3. Yeah. Left of -3 is going to be that. What am I going to plug in between these two? This is where it gets a little tricky.
What is -9/2 again?
It's like 2.12.
So then -2.5, I guess.
Yep. That's what square root of 9/2 is, 2.12, roughly. So let's go -2.5, right? What am I going to plug in between the next things? I'll give this a little bit more space here. What am I going to plug in right here?
0, probably.
Perfect, good. I was hoping you'd say that. And what am I going to plug in here?
2.5 again.
Perfect, good. And how about here?
4.
Good. Now, do you know the shortcut with your calculator?
Actually, no.
So here it is. What we're going to do is we're going to plug in. We're going to, this is the formula right here, the red formula that I have there, right? We're going to store, we're going to type in 0, and we're going to store that for X. Whoops. We're going to 0 store X. Remember me teaching you this before?
Yeah, now I remember.
Okay. And then be very carefully, make sure you do this carefully. I'm going to use parentheses. It's going to be 2x squared plus 9, that's in the numerator, divided by, I don't have to use a parentheses because the square root, man, keep doing that, because the square root will automatically give me parentheses in there. Got it?
Got it.
And remember, all I'm doing is trying to figure out if that's a positive or a negative. So that's the 0. That's the middle one that I'm figuring out. Hit enter, and it gives me a 3, which is what? Positive or negative?
Positive.
Positive. So I'll put a plus here. So it's increasing there. Got it? Now I store, I type in -4, and I store that for X. Store X, hit enter. And now I hit second enter, and it gives me back that formula. This time it's going to plug in -4. I hit enter, and it says no non-real answer.
Non-real.
So what does that? Yeah, what does that mean? Was I even allowed to plug that in?
No.
So it actually doesn't exist. It's not part of the domain to the left of -3, because there's a domain restriction on this, which we should have thought about looking at that. Do you see how the domain, how I can't plug in? If I plug in a value for X that's bigger than 3 or -3, so the same thing's going to happen over here. This is going to be DNE as well. So you actually can't even go over there. It doesn't exist over there.
Oh, why not?
Because look at the original function even. Are you allowed to plug in a number? What if I were to say, hey, what's the domain of this? what would you say?
Oh, yeah.
It's between -3 and +3, not including them. I'm sorry, including them. This includes them. This doesn't include them because you can't divide by 0. So 3 and -3 aren't even a part of this domain either.
So it would actually have to be like, for example, for intervals, it would have to be a parentheses, -3 and 3, not a bracket.
Correct.
Okay.
Correct. Yep.
Gotcha.
So we're gonna change this to let's see. I'm trying to think of how I can change this. Let's clear it. Let's store -2.5 for x. So -2.5 store x, hit enter. And now let's hit second enter, second enter, second enter. I might have to do it a couple times. There we go. Now it's going to plug that in, right? And I got what?
A negative number.
I got a negative. So this is negative here. And now let's store 2.5 for x. And hit second enter, and hit enter. And I get another negative number. Okay. So what does that mean about my original graph? What's happening? What is g of x doing in this region right here?
Decreasing.
Good. And what's it doing in this region?
Increasing.
And what's it doing in this region?
Decreasing.
Good. And so we're going to write that up here. So increasing from negative √9/2 to positive √9/2. That's where it's increasing. And it's decreasing from -3 to negative √9/2, and then also from positive √9/2 to 3. Okay, let's check this out just so that we can visualize it, okay? If I type into my equation, x times the square root of 9 minus x squared, and I graph it, I look at the graph, look what happens. Guess what that point is right there? Well, you can see what the point is. That point is 3, right? Or -3. You see it? That's where it ends. And that's on the right side, it ends at +3. And what's happening? What's it doing from, see this point right here that kind of looks like the min point? Hey, look, it is the midpoint. Look at what the value of that is. -2.1213. Does that look familiar to you? It's the square root of, it's negative square root of 9/2. Got it?
Sorry, it cut out for there.
Can you see what this graph does? You can see that we did it correctly.
Yes, I can.
So that's the min point, that's the max point. You know this is the min point because it's decreasing here and then it's increasing here. So that would be a min point. When it goes from decreasing to increasing, this is a min point. And when it goes from increasing to decreasing, that's a max point, as you can see on my graph to the right. So this is a min, and this is a max. Okay. Now they're also going to ask you in this problem to find where it's concave up and concave down, right?
Right.
So to find concavity, what I'm going to do, the next step is I'm going to take the double derivative. So to find concavity, I find the double derivative, and if it's the double derivative is positive, that means that it's concave up. And if the double derivative is negative, that means it's concave down. Okay,
Oh,
so
okay.
let's do that. So here's what I'm doing now is I'm taking this and I'm doing the derivative of this red thing, because that's my single derivative, right? So the derivative of that, what am I going to have to do to find the derivative of that?
Quotient rule.
Very good. So it's low d high, which is what?
Oh my gosh. Negative
Neg
4x.
Perfect. Minus high d low. What's d low?
1/2 times 9x squared.
9 minus x. Mhm.
Yeah, sorry, my
To,
bad.
to the negative 1/2 times.
Negative 2x.
Perfect. Good job. Which we did once before, right? All divided by low squared. Hey, look at this. Guess what I get to do to that? I get to take out that square root sign.
Yay.
Okay. So now we got to clean up this mess on the top. Okay.
Okay.
So I'm not really looking forward to.
I'm not looking forward to it either.
Yeah. So this is going to be,
Should we
let's see.
simplify it first? Like,
Yeah, we're going to we're going to simplify it. So that 2 is going to cancel with that 2. We're going to multiply this right here by the square root of 9 minus x squared on the top and the bottom. Actually, what we could just do is we could multiply everything by the square root of 9 minus x squared. Remember this trick? I think that would be the easier thing to do. So if I multiply the top and bottom by the square root of 9 minus x squared on the top and the bottom, this is called clearing the fraction. I'm going to multiply that on the top and the bottom. What I will get on the top is the square root will cancel with this one, right? And you'll just get negative 4x times 9 minus x squared. Got it? And when I multiply this by this whole mess, it'll just cancel this out.
really?
Yeah, because this is on the bottom, right? When it's got a negative exponent, negative 1/2 exponent, it's like this is on the bottom. And
Okay.
all of these things are being multiplied together. This and this and this are all being multiplied together. So it's like these just cancel each other out. Okay. So I get minus negative 2x squared plus 9 times just times x. Actually times negative x. Like that. I'm just looking at it, making sure I did it right. This is going to cancel with that. Excuse me. The 2's already canceled, but I have a negative x here and I have this here and the negative is still out here. So yeah, I did that right. All over. Now on the bottom, this is just going to be, if this is 1 and then I add a 1/2 to it, what does it become? 9 minus x squared to the
3/2.
3/2, exactly. And it's fine just to leave that like that. So let's clean up the top now. This is going to be that negative is going to cancel with that negative. So that's just gone now. So this is just going to be negative 2x cubed plus 9x. And this one right here is going to be negative, what's 9 times 4? 36? Negative 36.
Yeah.
Negative 36x minus 4x cubed. No, plus 4x cubed. Right?
Right.
Because the negative times a negative positive. So always check your work as you're doing it to make sure you don't make any silly mistakes. So then this just simplifies to 2x cubed minus 27x, which is very interesting how clean that turned into, all over 9 minus x squared to the 3/2. That's your double derivative, unless I made a mistake. Okay, so what are we going to do? We're gonna solve. Let's see. 2x cubed minus 27x. I'm going to go to the next page. 2x cubed minus 27x. That's the numerator. And 9 minus x squared to the 3/2. 9 minus x squared to the 3/2. That is my double derivative. So what am I going to try to do now? Set the top and
Bottom equal to 0.
the bottom equal to 0. And of course, I always should check, well, what's my domain and range? I still have to consider my domain and range. Remember how my original domain and range is what? Or not range. What's my domain? My domain, which I should have thought of at the very beginning, which I didn't.
Is -3 and 3, which I actually had a question on, to be honest.
The domain is from -3 to +3. So I don't even have to consider this left of that or right of it. Okay, so if I get any answers for this that are left of -3 or right of +3, I can just ignore them because there is no graph to the left of -3 or to the right of +3. That makes sense? So
Yeah.
setting this top equation, 2x cubed minus 27x equals 0. That means, let's factor an x out, 2x squared minus 27 equals 0, which means either x equals 0 or 2x squared minus 27 equals 0, which this would mean that 2x squared equals 27, which means x equals the square root of 27/2. Oh, plus or minus, don't forget the plus or minus. So there's one, there's another. Let's see if that's within our range. 27/2, the square root of 27/2. It's bigger than 3. So do I even have to worry about that?
No.
It's not. I don't have to worry about it because those are bigger than 3 or smaller than -3. So the only one I have to worry about from the numerator is x equals 0. How about in the denominator? What's the only thing I have to worry about in the denominator? Can you see what that would be?
I think maybe also just 0.
It's x equals plus or minus 3, not 0. Plus or minus 3, because all I'm basically doing is setting this equal to 0. We already did that once before, right? So it's just plus or minus 3, but do I even have to consider those? Well, I kind of do. I kind of leave those in there, right? Because those are going to be my endpoints. So here's -3, here's +3, here's 0. Those are the only things I have to worry about. And I don't have to worry about this, and I don't have to worry about that, because those are not part of my domain, right? So all I have to do is plug in something in here. What should I choose?
I would choose -2.
How about -1?
Yeah, that's probably
Wouldn't that be a little bit easier, probably?
Yeah, it would, my bad.
Yeah, it would probably be easier. So if I plug in -1, this is going to be a negative still. This is going to be a positive, right? So this is going to be a -2 plus 27. So that's going to be a positive over. And if I plug in -1 here, that's going to be squared. So it's going to be 8. And what's the cube? What's 8 to the 3/2 power, positive or negative? It's positive. So a positive divided by a positive is a
Positive.
positive, which means in this region it is what? Concave
Up.
up. Good. Now let's do the same thing, but let's plug in 1 because that's in this next region. If I plugged in 1 in the numerator, it's going to be
Positive. Oh, actually, no, negative.
Yeah, in the numerator, it's going to be a negative. And in the denominator, it's going to always be a what? Positive. So what's this going to be? Negative, which means it is concave
Down.
down. And do you remember what our graph looked like?
Yes, I do.
Do you see how it's concave up in this region?
Mm-hmm.
And it's concave down in that region. So it jives, it doubled, jives with what we were doing.
Jives.
Okay, got it? So you would write concave up from -3 to 0, and you write concave down from 0 to 3, and leave them as open intervals. Okay.
Okay. The one thing I had a question on was like for the domain for 3 and -3.
Yeah.
Since the square root of 0 is technically 0, they would still exist. So wouldn't it actually be brackets like you put now instead of like parentheses, which like
Well,
were...
when you talk about concavity or increasing, decreasing, you're always talking about that on an interval, on an open interval.
Oh, what's an open interval?
This is an open interval. A closed interval would be with the brackets.
Oh,
So you always talk about increasing and decreasing and concavity. You don't really look at the endpoints of them. It's defined on open intervals. It's not really defined on closed intervals. Closed intervals are for when you're talking about domain and range. That's when you might have a closed interval or an open interval. But I'm not talking about domain and range. I'm just talking about what's happening in this interval, or on what intervals is it increasing. And it's increasing from here to here. It's decreasing from here to here. You can ignore the endpoints. The endpoints don't really matter.
got it. But like, to be honest, just like you were just discussing earlier, the range of g of x would be brackets, correct?
The range would be,
Yeah.
yes, but that's not what this question was. This question was, yeah. But if we were talking range, because the range of this particular function, well, you'd have to find out what that value is, right? Yeah, it's 4.5. That's what the value is. So the range of this is, it gets as high as 4.5 and it gets as low as -4.5. So if you were to write the range of this, if they were asking you what's the range, I'll just do this on the next page. The range would be from -4.5 to +4.5. And the domain would be from 3, including 3, I'm sorry, -3, including -3 to +3, because you're allowed to plug in 3. Look at the equation. Your equation was y equals x times square root of 9 minus x squared. If you plug in 3 here, you're just going to get 0 in here. And 0 times x is 0. That's not a problem. And if you were to plug -3 in here and here, you get 0 inside here, which is not a problem. But if you plugged in 3.1, you have an issue, because then you'd have a negative underneath the radical, and you can't take the square root of a negative number. That's why the domain is from -3 inclusive to +3. But the double derivative isn't defined at -3 and +3. The derivative, not the double derivative. The derivative, look at the derivative, this red graph here. The derivative, you see the difference between this one?
Yeah.
You're not allowed to plug in any numbers bigger than 3 or smaller than -3, because that would give you a negative underneath the radical. But you're also not allowed to plug in 3 or -3, because that would give you what in the denominator?
Negative number inside of a root.
No, it would give you 0 in the denominator.
Oh.
And you're not allowed to divide by 0. So the domain for this one, if I were to ask you, hey, what's the domain for the derivative? The domain for this one is actually going to be from -3 to +3, not including them, because
Um,
you can't divide by 0, and that's what you would be doing here. And same with the double derivative. What's the domain of the double derivative?
it would be -3, +3, not included.
That's right, because you can't divide by 0, and that would be divided by 0 if you did. Yep.
Okay.
Okay, does that make sense?
Yeah, I think that's starting to make sense. Yep.
All right.
All right. Thank you so much for meeting with me.
Hey, no problem. And good luck with the